A lot of you guys have been asking how I created this building from my Utopian metaverse animation.
Teach me.
If you haven't watched the animation, you can watch it by clicking the I button. So in this video, I'm going to show you how I created that using geometry nodes inside of Blender.
Before we get started,
let me introduce you to my new product called the Procedural Utopian Buildings, brought to you from the award-winning animation The Utopian Metaverse. It is a pack of semi-procedural utopian buildings with fully customizability, with infinite variation and trees as well. There are 3 geometry nodes generators with 11 default presets. You can even use your own assets. All the parameters can easily be modified from the geometry nodes modifier. I've also dropped the price from $40 to only $19. And also, if you leave a nice comment down in the comment section below, then I'll give away a coupon code to get extra 25% off on my procedural utopian buildings to 10 people. Now, let's begin the tutorial. And I don't want to plagiarize, so this building does actually exist in real life, and its name is Chao Shu Yin Yang. Sorry, I don't know Chinese. And fortunately, it has a second name which is called Agora Garden. So that's what I'm gonna call it for the rest of this video. I use PureRef to collect all my references, and it's an awesome software where you can put a lot of images to create a mood board. So if you look at the building, you'll notice that it's mainly made up of 2 parts. The first is this part, which is actually only one story/floor, which is being repeated. So we just have to model that once. Then we can create an array of that using geometry nodes. Then on top of that, there's this type of structure which we can create separately and add it on top of the building. Then we'll make this building twisted. So before we begin creating the building, let me show you what we are going to create. So here's what it looks like. We can control the height of the building. We can control how twisty it is, and you can go all crazy. You can control the rotation speed. And you can also manually rotate this if you want. And we also have trees. And if you are thinking, what? These are looking very bad. The reason is that these are placeholders and they are only for the viewport. And in the render, the high polished trees will be rendered. Okay, so now let's begin creating this. So I'm going to hide all this. So let me unhide the instances folder. Now, I'm not going to show you how I model these things because there are a bazillion tutorials on how to model something, but right now I'm going to focus on the geometry nodes aspect. So these are the objects that make up the first floor or story, whatever you can call it. And to create this, I'm using a lot of modifiers. And if this is looking very complex to you, believe me, it's not. There are a lot of modifiers being used. Like for this one, it's just a simple mesh, but I'm using a mirror modifier to mirror this and a bevel modifier to bevel the edges. Then again, a bevel modifier to bevel out these edges. And for the fence, you'll see that it's just a cube with an array modifier to create an array of the cubes. Then a curve modifier to wrap it around this floor to make the fence or balcony. I don't know what that is called. Then I'm also using a mirror modifier to mirror that. And this part is mainly made up of a cylinder. So yeah, that's how I made it using a lot of modifiers like array, curve, mirror, and bevel modifiers. And the reason I'm using a lot of modifiers to create this is when we are using modifiers to create something, we have a lot of control. We can modify the geometry very easily. One thing to keep in mind is the origin of the story has to be at the bottom. And as you can see, the origin is here at the bottom of this cylinder. And I've also parented everything to this cylinder. to make it nice and clean. But here's the problem. If you take a look at the floor of this building, you'll notice that this shape is like a pyramid, but the floor next above it has a shape of a pyramid but inverted. So what I'm trying to tell you is there are two floors. The second floor is the same but is inverted. So what I did for that is I duplicated everything and put that in a separate collection called Agora Garden Floor 2 Assets. And in this one, what I'm going to do is I'm going to select this part. I'm going to edit mode, select everything, and I'm going to scale it on the z-axis by -1 to invert it on the z-axis. And because we inverted it, we also have to fix these wrong normals. So let's press Shift N to recalculate the normals. Now here comes another problem. We want to use this collection as our first floor, and we want to use this collection as our second floor. And these are two separate collections. So we could just select all these objects, apply all the modifiers, and make them one single object, and do the same for the second collection as well, and put the objects in a single collection and use that to create the building. But the problem that occurs when we apply everything and join them together, we will not be able to modify the geometry very easily. It will be very difficult. And there can be a lot of ways to get around this problem, but here's the solution that I came up with. And let me just hide these objects so you don't get confused, or if you're already confused, you don't get over confused. So let me hide this modifier. So what I did is I added an object. It can be any object, it doesn't matter, because at the end of the day, it's going to be replaced. Then in geometry nodes, I use the first floor collection as the group output. So what we are doing is we are creating an instance of this collection, and this is a single object. One thing you have to keep in mind though is the object has to be in the center of the world, because if it's not, let's say if I move it here, you can see that this moves as well. And the origin point is far here. And that's not what we want, as I already told you. We want the origin point at the bottom. That's why you have to keep this in the center of the world. And when we do that, the origin point is at the bottom, which is exactly what we want. And then I put this in a separate collection called Agora Garden Stories, made a duplicate of this to create the second story. Now this time, I'm doing it a little bit differently. I'm using the second collection for instancing, but I'm also using a transform node. So let me just show you what happens if I mute this by pressing M. You can see the origin point is here and the floor is up in the air. And that is because this floor is 4.158 meters on the z-axis. It's not in the center of the world. And you could move that in the center of the wall, but it starts to intersect each other and it gets very hard. So I'm just going to keep it 4.158 meters above on the z-axis. Then I'm going to add a transform node and move it down by negative 4.158 meters, or whatever it is in your case. Now we can just use this collection to create the building. Now I'm going to hide these original collections. I also created another collection called Agora Top Floor Building Assets to create the top floor. And as you can see here that this is containing multiple objects as well. So I did the same for this as well. And keep in mind that you have to keep it in the center of the world. So I added another object and I just instanced that collection. And we don't need a collection for this, as this is only a single object. And now we can also hide this collection as well. Now that we have prepared everything to create the building, let's begin putting it all together using geometry nodes. So let me just add an object. It could be any object. It doesn't matter because it's going to be placed in geometry nodes. So let's just add a cube to make him go happy. Now let's go in geometry nodes and create a new geometry nodes modifier, and let's rename it to Agora Garden Building. And if you're Chinese, you can use the Chinese name. And if you are a beginner to geometry nodes, then you should watch my previous tutorials on geometry nodes for beginners. You can watch them by clicking the I button or by following the links down in the description box below. Okay, now how do we create an array of these stories? So the node we need is called mesh line. And it's exactly what it says. It's a mesh of a line. And it's not just a line, but it has vertices on it. And we can control how many vertices it has using this count value. So if we type 1 in here, you'll see that we have nothing. And that's because it has only one vertex now. So let's set it to 2. And the distance between this vertex and this vertex is defined by this offset value. So what we can do is we can instance these floors on each vertex of this line. To do that, we need to add a node called instance on points node. Now we want to use this collection as the instances. So we can add a collection info node, or we can just drag and drop the collection from the outliner into the geometry nodes editor, and it is very, very awesome. So let's plug this geometry into the instance, and we want to separate the children from the collection. So let's check that, and we want to reset the transformations of the objects. So click on that, and also we want to pick all of the instances from the collection. So click on pick instance. And as you can see, this is not looking good at all. That's because the distance between the two vertices is set to 1. So all these stories are squashed on top of each other. So what we need to do is we need to specify the offset. So let me just hide this cube, and let me unhide my Agora Garden Floor 1 address. And here you can see that this is 4.17 meters tall. So now we want to enter the height of our story into here. So it's 4.17. Now you can see that this is working. And if I set the color to random, you can see that by default, geometry nodes uses our first object as the first story and the second object for the second story, and so on and so forth. So we don't need to do anything for that. It's already working. Let me increase the amount. It's 19 floors, I guess. Now what we want to do is put this top floor on top of the building. So we can just drag and drop the Agora top floor object into the geometry nodes tree. Now what we want to do is we need to join this object to this geometry. So we can do that pretty easily by adding a join geometry node, or what I like to do is with Node Wrangler add-on enabled. If you haven't enabled that, then you should do that first. Now you can hold Ctrl Shift left click and connect any two nodes that you want. And in this case, it didn't work, but we can just plug this into the join geometry node. And we did join it, but we can't see it. That's because you are blind. It is down here. So we need to put it on top of the building. So we can add a transform node and move it on top of the building. And instead of guessing what the height should be for our top floor, you can tell that the height is the number of floors that we have multiplied by the height of one floor. And if you didn't know, you can do calculations inside of Blender. So it's 19 floors multiplied by 4.17. That's the height of our story. And when we do that, Blender does the calculation. And it's very awesome. But every time when we change these values, we don't want to go and change this manually each time. So what we can do is we can plug this socket into the group input node. Now we can control that value from the geometry nodes modifier. And that is very awesome and handy. Now that we have got this input, we can modify it. So let's add a math multiply node, and we want to multiply the count by the height of our building. So let's plug this into the group input node as well, and we are going to use this for the offset. But before you quickly plug this into the offset like a stupid, you need to know that this is a float and this is a vector. A float is just a single value, and a vector is a group of three values x, y, and z. And you can tell that it's a vector by its purple color. So what we need is we need to use this value only for the z-axis, but we don't have sockets for each individual axis. So what we can do is we can add a combined x, y, z node and connect this into the z-axis. Now we can plug this into the offset as is a vector now. Now the height of our one story was 4.17. So let's type that in. Now we can use this value for the height of our top floor. But as it is a vector, we need to add a combined x, y, z node again and use that for the z-axis. And now if we change these values, ta-da! The top floor sticks to the top. And that is very, very awesome. And for our ease, we can also rename these values. So I'm going to rename this to height. And I'm going to rename this one to height of one story. And also let's organize these nodes a bit so that we don't forget the next day what we did. So let's select these nodes and press Ctrl J to add a frame. And we can now rename this. So I'm going to rename this to top floor. Select all of these nodes and I'm going to frame these as well. And I'm going to rename this one to base building. You can rename it whatever you want, whatever fits for you. Okay, what we're going to do now is we want to twist our building. So to get this effect, it's very easy. We only need to rotate our instances as they move up on the z-axis, and that will give an effect of twisting. So there are a lot of ways to do this as well. I'm going to add a rotate instances node to rotate our instances, and it's giving an error and it's saying realize data and input geometry is ignored because we are using an object info node. Here it's not an instance, so let's make that an instance as well so that it doesn't cause any issues. Now we can rotate our instances, but we want to affect the rotation by the z position. So what you can do is we can hold down from the socket and search for a position node. Now the effect is a bit intense. Oh, sorry, I meant to say intense.
It gets confusing here.
But first, we only want the z-axis to be changed. So what I'm going to do is I'm going to add a separate x, y, z node, and because it's a vector and we want to separate all the three axes. Now we want to use the z position to change the z rotation. So let's add a combined XYZ node and plug it into the Z axis. Now let's use this for the Z rotation. Now to control the twistiness, we can add a mask node in between, set it to multiply, and change the value. It's very hard to control this because it changes so fast. So what you can do is you can again add a mask node and set it to multiply, and I'm going to multiply it by 0.015. Now we can easily control the twistiness of our building. How cool is that? Just look at this. And you can go all crazy if you want. I'm gonna set it to 1.5. This is looking great. And we can also plug this into the group input node. So let's plug that in. And instead of going all the way to the group input node, you can actually add another group input node by typing it in. And now we have another group input node, and that makes it a lot nice and tidy. So let's rename this value to twistiness. Now what we want is we want this to be animated. So when we play the animation, it just keeps rotating. So for that, we can add another math node and just set it to add. And when we change this value, it keeps getting rotated. So we want this value to be continuously increasing. So we could just type #frame. That's the old way of doing that. Now we have a node called scene time, which we can just use for continuously increasing values. Now you can see that this is working pretty awesomely. Is that a one? I don't know. Now let's again add a mass multiply node and use this to control the speed. So when this is set to 1, is normal speed. When it's set to 5, is 5 times faster. So I'm going to set it to 1, and I'm going to add this to the group input node as well. And you can press Ctrl H to hide the unused sockets. Let's rename this value to speed. I am speed. I am speed. Now we can also frame these together by pressing Ctrl J. And I'm going to rename this to twisting. And ta-da! This is looking awesome. So that is it for this video, guys. In the next part, we'll be creating the trees for this building. And if you learned something from this video, please give a thumbs up and don't forget to hit the subscribe button for the next part, which will be uploaded tomorrow. Until then, I'll be back.